Assalamu alaikum everyone. Welcome to our CSE 316 term project Lookout 32. I am Mohammad Zarif Ul Alam and my partners are Sheikh Azizul Hakim and Najibul Sarker. We have built an Atmega 32 based warning device for safe driving. Approximately 1.3 million people die each year from road accidents all over the world. There are many accident prone points in roads and highways. Road signs are used to warn drivers. But how effective are they? Lack of proper warning system is one of the major reasons why we can't avoid road accidents. Road signs are hard to see in case of harsh weather and also in night due to poor visibility, especially in Bangladesh where working traffic lights are uncommon. We intend to make a viable alternative solution to this problem. For this purpose, we have designed an in-vehicle alert system to warn the drivers from these risky locations. These risky locations are determined from historical data, which can be regularly updated with the data from our servers. Data can also be collected for future analysis. In case of an emergency, there is an option for an emergency SOS button, upon pressing which a message will be sent to the nearest emergency service. Now we will look at the components.
So this is the setup of our device in a car. Now let us look at the components. So as a processing device, we have an ATmega 32 and we have our SIM 808, which is a GPS, GPRS and GSM module, and we have our LCD display to show the relevant information. And to power the LCD display and the ATmega 32, we are using a 9-volt battery and a voltage regulator to get the 5-volt output, and this 5-volt output is powering both ATmega 32 and the display. And we have another lithium polymer battery which is powering our SIM 808 module. Now let us see how the circuit is completed. Now let us connect the lithium polymer battery like this, and let us complete the circuit here. We can start our GSM module like this. Now we can show the appropriate outputs in the LCD screen. Now let us look at two additional features. One is a buzzer, which will be used as an accident alert system, and we are connecting the buzzer to the A0 port, the ATmega 32, and we also have a push button, and this push button will be in emergency situation, this push button will be used to send an SOS signal.
So those were the components we used in our project. Let's now turn to our project workflow, which primarily consists of Atmega and server processes. On powering up the Atmega, the GPRS and GPS settings are initialized properly. It will then use the GPS module to extract the user's current location and use the GPRS module to send the information to the server, which calculates the distance from any of the predetermined risky locations. If the location is within a certain threshold, the server will send a feedback to turn on the alarm. Otherwise, the alarm will remain off. Then the Atmega will again calculate its location and the process will continue all over again. The server will also use the information it gathers to prepare relevant statistics. The user can also use the push button to generate an SOS signal which gets the current user location and sends it to emergency services. Now let's take a look at the whole process in action.
We are initializing our GPRS and GNS. The power is okay. The RMC is okay as well. The GPS setup has been done. The location has been 3D fixed. This is our latitude. This is our longitude. And the data has been sent over HTTP. We have received a response. And since we are near an accident prone location, the buzzer is on. We can hear that. And the process will now be repeating again. Location has been 3D fixed. This is our latitude and our longitude. We're sending the data to the server. Since we're not in an accident prone location, we are being shown that you are safe and the buzzer is not on.
Now we'll be looking at the SOS functionality of our device. The SOS functionality is implemented as an active low push button. A falling edge on that port will generate hardware interrupt 1 and a message will be sent to a predetermined number. Let us look at a demonstration of the SOS functionality. The system is clearly doing something and we're issuing an interrupt, and immediately a message is being processed. A message is being sent and we can see that a message has arrived. Thank you.
We have also added some server-side statistics uh, in order to help with some analysis. So this is one of those examples. So as you can see, we have added some bar plots which shows the relation between our predetermined risk locations and the average number of cars that passes through them. We also have a dash map which shows these locations with their data on the Google map, which makes for easier analysis. Let's take a look at some specs of the project. Our GSM, GPRS, and GPS module, which was SIM808, was controlled by the ATmega using relevant AT or attention commands. Data communication between the ATmega and SIM808 was done via UART or Universal Asynchronous Receiver Transmitter with a baud rate of 1200. In terms of peripheral devices, we use the I2C or Inter-Integrated Circuit Protocol to communicate between the ATmega and the LCD display. We also use the interrupt subroutine to activate SOS through a push button. That ends the overview of our project. Now, excessive and reckless speeding is also another leading cause of accidents in this country. So we would like to incorporate a speed limit violation detector with this setup. But the question is how? We can use the GPS to get a very rough estimate of speed, but this is highly unreliable and inaccurate. Instead, we explored the possibility of using LiDAR in this case. So LiDAR stands for Light Detection and Ranging, which determines ranges by targeting an object with a laser and measuring the time for the reflected light to return to the receiver. We explored the possibility of including TF Mini, which is a micro LiDAR module, but there are quite a few challenges, including its cost and the actual interfacing and implementation of the device. Overall, we did face some challenges during this group project in the pandemic situation. We couldn't demonstrate the proper execution of our model due to the ongoing strict lockdown. Also, debugging the SIM808 module using the ATmega proved to be very challenging, compounded with the fact that there are very few resources available online on this topic. Figuring out that our GPRS error occurred due to SSL certificates or debugging how to properly triangulate the GPS module are only some of the many challenges we faced throughout the project development. So, this concludes our project demonstration. We thank the audience for listening, and if you have any questions, please feel free to ask.